All right, good evening. It's 6 o'clock, so we'll go ahead and get started. So the material for this week is all about strings, really describing what a string is, what we can do with a string, and yeah, really what a string is and what we can do with strings. So let's start off with discussing what a string is. So a string in Python is just a sequence of individual characters. Just like, a written word in really any language, a word is made up of individual letters. And it's really no different in Python, to where the entire string is represented by individual, one at a time characters. So let's see what we can do with those individual characters. So first, let's start off by making a string. We'll just say S, variable S. This is a string, right? So S is a string, and this is what it is equal to. But if you'll notice, of course, we have individual letters. There's a T, there's an H, there's an I, there's an S, there's a space. A space is still an individual character, I, S, and so on and so forth. So they're actually individual characters that make up this string. So we can print the string, right? Print S. Of course, if we do that, let's run Python, run the right code. Yeah. Python 3 on my file. And of course, it just prints out, this is a string, as we, completely expect that it would, because we've been doing this a lot already, right? Printing out strings. But now whenever I say a string is a sequence of characters, what if I wanted to just access the very first character? What if I only wanted to access the T? I don't care about the rest of it. I just want to talk about the T, the first character. So let's have another variable A, and our A is going to represent an individual letter, an individual character of that string. So how do we get an individual character of the string? Well, we have S, which is the variable for the string, and then we have these brackets, right? And inside these brackets, I will put a number. Now, what does this number represent? It represents the index of the character that we want to access. This means the character in the 0 place in the string. Now, indexes in a string start at 0. It's really the same for all programming languages, in C, in Java, in JavaScript, really any of those languages, to include Python. 0 is the number you start with. So T is in the 0 place of the string. H is in the 1 place. I is in the 2 place, and so on and so forth. So this is how you access an individual letter, an individual character in that string. You do it with the variable name. You have the brackets. You have the brackets. And inside the bracket, you have the index of the character you want to access. So if we say A is equal to this string index 0, we're talking specifically about this 0, the character in the 0 place, which is the T. So if we print this A, it should only print out a T for us. Let's run that. As you can see, we only get the T printed. So if I wanted to access, say, this S, well, let's count what place that is. So that's T is 0, H is 1, I is 2, S is 3. So if I wanted to access only this S character here, it's in the 3rd place. And so this gives me that character in the 3rd place. If we save it and run it, it should give us an S. And of course it does. It says the character in the 3rd place is the S. Okay, so that's how you can access individual letters. If you wanted to access the last letter, the G, well, let's what place is that? So that's 0, 1, 2, 3, 4. Remember, you have to count the spaces. The spaces is a character. So it counts as an index. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It is index 15. And if we print that out, we should get the G in string. And sure enough, there we do, the G in string. What happens if we miscount? Let's say if we put 40 here, right? Obviously, you know, there's not a 40 index in this string, right? You know, let's see what happens if we put in something that doesn't really exist. Our program crashes. And you know, it gives us the error, index error, string index out of range. That means we have given it an index that doesn't really exist because this character, excuse me, the string isn't that long. There is not a 40th index in this string. You know, there's like 15 or 16 or something like that characters in the string. So that's as high as you can go. You can't go past the end of the string, or you will get your program crashing. Okay. So let's set this aside for just 1 second, and we'll come back to it. But just remember, that's how we access an individual character. So what else can we do with a string? Let's see, how long is the string? How many characters are in the string? Let's make a new variable called count. And it's real easy. There's a built-in Python function called len. It stands for length. And inside here, you put the string. And then here we'll print out the count, right? So this will tell me how long is that string, how many characters are in the string. And this should be, I think, 16. I think it should tell us 16. I think that's how many characters are in that. See, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, there are 16 characters in the string. So this length of the string variable will tell us how many characters are in it. We save that in the variable count, and then we print out what the count is. If we run that, it should tell us 16. And it does. It tells us there are 16 characters in that string. And of course, if we type more stuff here and save it and run it, you know, it tells us this string is 40 characters long. Okay. So how does this help us, knowing how long a string is? Well, you know, a second ago, you know, I told you that this is how we access an individual character in the string, right? This will give me the index at 4. Well, what if I want to know what is the last character in the string? I need to know the index of this f, right? So how could I get the index of the f? Well, I could manually count it up. You know, 1, 2, 0. Remember, it starts at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, right? So if I wanted the last character, I could do 39, right? Print out the A, and that should give us the F there, right? And there it does, you know, prints out an F. Okay, well, what if this was shorter? Yeah. Now what is the last character? Well, you know, do I need to count that all out again? No, you know, that's going to be very problematic if we change the string all the time. What if we got input from the user, enter a string, right? And that the user can type in however long of a string they want. So how do we access the last character? Well, it's kind of a combination of these two things, right? The length tells us how long that string is. So if we go in here, we'll have the user input a string, and then we'll just have it tell us how many characters are in it. If we run it, I'm going to enter a string of A. Right? Well, let's do A, B, C, D. it should tell me 4, right? The character is 4 long, and it does. The count is 4. So how can we access the last character? So I have A is equal to string, and inside here we need to put a number, right, of which character we want to access. Well, if we want the last one, then we need to know the length of S, and then we have to minus 1. So let's imagine I type in ABCD again, right? S is equal to ABCD. We could take this out for a second, and then let's print A at the end. So S is ABCD. Let's put that here as a comment. S is equal to ABCD. That's if I typed that in at the keyboard. Imagine that's what I type in. So here, that means the length of S will be equal to 4, right? Because there's 4 characters in it. So if I do that, if the length of S is 4, why do I need to subtract 1 to get to the last character? Because if we look here, A is 0, B is 1, C is 2, D is 3. So the last character is index 3, but the length is 4. So that's why we have to subtract the 1. And it really boils down to because we start counting indexes from 0. We don't start from 1. A is 0. A is not 1. So that's why you have to tack on the minus 1 there. But this will be how you can get the last character of a string of any length. It doesn't matter what I type in. This will get me the last character. And then we can just print it out. So let's save it and let's run it. And if I do like my example, if I say ABCD, of course it tells me the last character is D. But as you see, this works for a string of any length. Explanation point. Enter. And it tells me the last character is the exclamation point. And that's right. So that's how you can access individual characters in this string. And this is kind of how you can get the very last character without knowing ahead of time how long the string is, because this gets you how long it is. You know, if we wanted the next to last character, you know, we could subtract 2 there. We run that and we say A, B, C, D, E, F, G. It should tell us F, right? And it does. That's the next to last character. And then you could go and keep repeating this down to, you know, minus 3 if you wanted to, and keep counting backwards from the end of the string. All right. So that's kind of what the length of the string is and how we can use it. So now let's talk about doing something with the characters. So I've shown you how to access individual characters. So now let's do something with those characters, right? And so to do something with each character, we need to be able to loop and access access each individual character. And we can do that with a loop. And if you remember from last week, we really have kind of 3 different kinds of loops. We have a while loop, we have a for loop, and then we also have like a for range loop. And we'll show each of these about how we can use each of those kind of loops to access each individual character. So let's start with the while loop. And it looks like this: while, and this is kind of pseudocode, while something is true, and do something here. Do some more stuff here, etc. All right, that's kind of pseudocode for a while loop. So how can we make something as true so that it keeps looping as long as there are characters in the string? Okay, well, let's look at it like this. Let's say we have a variable called I, and we'll start it out being 0. And a lot of this is similar to what we covered last week in loops. So we say while I is less than the length of S. And how does that work? And then here at the end, I plus equals 1. So how does this work? So I will start out being 0. Let's still imagine imagine S is equal to A, B, C, D, right? Imagine that's what we type in. S is A, B, C, D. So here at the beginning, I is equal to 0. So this is saying, is 0 less than the length of S? And if the length of S is, if S is A, B, C, D, then the length of S is 4, right? This is always going to be 4 if that's what I type in. So it's saying while 0 is less than 4. So is 0 less than 4? That is true. So I'll execute these statements. So we'll do something else. Then we'll make I go up by 1. So now I is 1. So say, is 1 less than 4? That's true. So we'll do some more stuff. I gets increased by 1. I is now 2, and so on and so forth. So what can this I also represent? Well, I just showed you how to get an individual character of a string. You know, it looks something like this. I is equal to S. You know, a 0 gets me the first character. 1 gets me the second character. 2 gets me the third character. 3 gets me the fourth character, so on and so forth. So what if instead of a number, I have I? Right? So the first time in the loop, I is equal to 0. We're going to say A is equal to the string at index 0, which is the first character. And then we're just going to print out the A. We're going to make I equal to 1 now, because it goes from 0 to 1. While 1 is less than 4, that's true. So now A is equal to the string at index 1, which is the second letter. Right? So what we'll do here, I'll print out what I is, and I'll print out what A is. Okay? So I will, when I print I, it'll show me where I'm at in the loop. And then I'll also print A, which is the individual letter that I accessed. And what you'll see a bunch of printout statements that says like 0A, 1B, 2C, and so on and so forth, as long as this is what I type in. So let's run that. Let's put A, B, C, D, and there you go. When I is 0, the letter is A. When I is 1, the letter is B. When I is 2, the letter is C, and 3 is D. And again, this works no matter how long of a string you type in. I typed in this long string, and it actually, you know, shows a lot more here because it's accessing each letter individually. So let's take out the printing of the I just so we can see each individual letter. And you'll see this is my string, and you can see it's kind of printing out each letter one at a time because it's accessing letters one at a time. It's printing the individual letter while it's doing this loop. So this is a simple while loop accessing each individual character of a string. Now you could do interesting things besides just assigning it. You know, A is just getting what the value is. But you could say if A is equal to a Y, you know, whatever, then print I found a Y. You know, whatever. That's a silly example, but it shows the point that whenever you access the letter, you can then do anything with this letter you want to do. Here, we're just making some kind of comparison. And if the comparison is true, then I'm going to print that out. So if I run that, you know, enter a string, this is a string. As you notice, this does not contain Y, so it ends up not printing anything. But now if I put in a string that does have a Y, I found a Y. You know, if we put in a string that has more than one Y, then it does, I found a Y 3 times. That's because there were 3 Ys in that string. Silly example, really, you know, just looking for a Y. But it's showing the point, though, that you can do anything with this individual letter that you want to do with it. All right, so that's how you access it with a while loop. Let's look at the for loop. So another way we can access each individual letter is with a for loop. It looks like this. For, I'm going to say C in S. Let's print the C. And then we'll kind of do the same thing. If C is equal to Y, we don't need those. Then we will print I found a Y. So this loop looks a little bit different when we say for C in S. So what is S? S is a string, but what is a string? A string is a sequence of individual characters. So this is really saying for each individual character in this string. So this will loop how many ever characters are in the string, and each time through the loop, C is equal to that individual letter. So again, imagine I typed in ABCD here. The first time in the loop, C is going to be the letter A. The next time through the loop, the variable C is the letter B. The next time through the loop, the variable C is equal to the character C. And then the last time, it'll be equal to the character D. The thing you need to remember here is this is the string that you're doing the loop on, and this is going to be the variable for the individual character. And this can really be anything. You can name the variable whatever you want to name it. And that's fine as long as, in here you use the same variable name. The point is the name of this variable doesn't matter. I picked C because it helps remind me of character, but it doesn't have to be a C. It can be this. It can be RR. Whatever. That works too. And so this will loop over each individual character. It'll print the individual character. It'll check, is the individual character equal to a Y? And if it does, it prints I found a Y. So let's run that. Enter a string. This is the string. You see, it looked at each individual character, but not once did it say I found a Y, because there's not a Y in there. Let's put some Y's. Let's put QWERTY. And you see, it looks at the Q, looks at the W, then the E, then the R, then the T, then, oh, it found a Y. It says it's printing the Y right here. It's saying, is this variable equal to Y? In this case, it is. It is a Y. And so then it prints, I found a Y. Same thing if we put Y. It's looking at the character Y, I found a Y, and so on and so forth. So that is the second way really you can use a loop to access individual characters. The last way, again, these are just really the same loops we ran last week. We could say for I in range length of S. Oops. That there. Let me type it out and then we'll look at it. A is equal to S of I. A lot of these look very similar because really loops are all very similar. Print, I found a Y. So how's this one work? How's this loop work? You should have seen this range loop from last week. And so, we've already talked about what the length of S is, right? The length of S tells us how long the string is. And if we imagine again, if I type in ABCD, then the length of S is 4, right? So what does this I in range of 4 do? What this will do, it'll do a loop where I is equal to 0. Then the next time I is 1, then I is 2, then I is 3. It'll count up to, but not including the number you put in here. So if this number here turns out to be 4, then you will loop 4 times, and this will be the value of I. If the length of S is 3, then that's what it'll look like. I will be 0, then I will be 1, then I will be 2. Said it goes up to, but not including the number here. If this ends up being 55, then I will go up to I equals 54. If the length of S was 55, it'll go up to, but not including the S. And the reason why that's important is, like I mentioned earlier, where the letters in a string start with index 0. That's kind of why we get the same thing for a loop here. So if we run this loop, we're really going to get the same inputs we've gotten for the other loops. Enter a string, we'll put quirt. Oh, I actually wanted to print the letter as well. Let's print the letter and then check if the letter is equal to Y. So let's run it with QWERT. As you can see, it's printing out individual letters, but it never prints out I found a Y because there's not a Y. Let's put QWERTY UI, whatever. You see, accessing each individual character, and then after we get a Y, it prints I found a Y. So really, these are three different ways to loop and access individual characters of a string. There's no one way better than the other, and all of them are valid, and it's really up to you which one that you feel the most comfortable with. Okay. So what can we use this for? Let's imagine, well, I mean, this example, I put, checking for Ys. Let's say we want to count how many Ys are in the string. Well, we can do the same thing using a loop. Let's have a variable called count, and we'll use it to count up how many Ys we have in the string. So we'll start out count 0. We'll have our loop. We could use this loop. We could use a while loop. We could use the other for loop. Any one of them will work. But since I have this typed out, I'm already going to use this one. So we're already saying A is the individual character. Well, if we want to count up how many Ys there are, so we'll say if A is equal to a Y, increase our count. So if this loops over every single character in the string, anytime one of them is Y, it's just going to increase by 1 this variable count. And that is a basic counter. At the end here, we'll print the count. So this loop should tell me how many Ys are in the string I type in. So if I type in quirt, it's going to tell me 0. There are no Ys in that string. If I type in QWERTY, it tells me there's 1 character in the string. Type in whatever this is, Y, a bunch of other letters, it tells me there are 3 Ys in there. And again, the reason why this works is because I'm accessing each individual character. I'm checking if that character is equal to a Y, and then I'm going to increase this counter. So that's a useful thing to do when you're looking at strings, is accessing each individual character, and then you decide what you want to do with each individual character. But this is an example, a contrived example to count how many Ys are in a string. Okay, let's look at the next topic, and we're going to talk about string slices. So as we discussed, this string has individual characters. The first index is 0. The last index is what? Length of S, length of S minus 1, right? This is the first character, and this is the last character, right? So let's say we want a subset of the string. So this is better explained if I'm not inputting it. So let's imagine I have this string. Let's say it's the alphabet: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, R, S, T, U, V, W, X, Y, Z, right? That's the entire alphabet. So if we want to access the first character, it looks like that, right? Let's just call this first. The last character is that. Okay, well, let's print those out so you can see it is what it is. Print the first, And then we'll print the last. Of course, that should give us an A and a Z, right? And it does. It prints A and it prints Z. Okay. Well, let's say you want a subset of this. You don't want the entire thing. You want a string that say the first 5 characters, right? You know, the first 5 characters is A, B, C, D, E. Yeah, that's 5. Right? That's the first 5 characters, right? Let's say we want a string that is just the first 5 characters. We can access that with what we call a slice. Let's have another string. We'll call it another. And we want a subsection of the string. And here's how we access it. Not very dissimilar to the individual character, meaning we have the string variable and then we have these brackets. But inside here is what changes if we want to create a substring, you know, a subset of all these characters. Not a single individual character, but another string that is part of the string. As I said, let's say we want the first 5 characters, and here's how we do it. We first put the index we want to start at. So if we want the first 5 characters, this A is index 0, right? So we put index 0. Then we put a colon. And then in here, we put what is the last character that we want to access plus 1. It's usually kind of hard to remember, but it's plus 1. So as I said, we wanted the 5th character, you know, that's A, B, C, D, E. So what is the index of E? Well, A is 0, B is 1, C is 2, D is 3, E is 4. So we'll put the 4 plus 1, which ends up just being, you know, 5, right? So to print this, this will be a string that is the first 5 characters of this original string. Let's run that. As you see, it prints out the first 5 characters. This is the first 15 characters. You know, what is that? That probably goes up through like P or Q or something. Let's run that, and actually it goes to O. That is the first 15 characters. Okay. What if we want, say, let's say we want the last 5 characters, right? The 5 characters at the end of this, right? Which should be that's 5 characters there. What if we want the last 5 characters? It's actually a shortcut in here. So when we use these positive numbers, it counts from the front of the string. If we use negative numbers, it counts from the end of the string. So we could say from -5 to -1. Let's see what that gets us. Oh, well, I left off 1. -5. I'll leave it right there. I'll tell you why I leave that blank in a second. What the -5 does, it counts 5 from the end. So 1, 2, 3, 4, 5. So that's right there. So it covers those. Now, when I leave a blank space in here, if I leave a blank space before the colon, it implies I want to start at the beginning of the string. If I leave a blank space after the colon, it implies the end of the string. So when I put the -5 in here, the -5 means, you know, 5 characters, but the negative means from the end of the string. So I count 5 from the end, which gets me to the V. And then when I put the colon and a blank here, that means go to the end. So since this is -5, the blank means go to the end. It selects all those characters. Let's print that. As you can see, there you go. That's the last 5 characters. You could do the last 15 characters if you want. And that's the last 15 characters of the string. So that's what we call a slice. And you don't have to start at the beginning or the end. You can start in the middle. You can start at 5 and go to 10. You know, I don't know what that is. That's probably like, it's probably like those characters or something like that. You can count it up if you want, but it's probably like those characters in the middle. If we run that, and there you go. There are the characters from 5 up to 10. The thing you have to remember is this is not how many to get. This is the last one to get plus 1. So as you see, this doesn't get 10 characters. As you see, we only got 5 characters, but it's saying start at 5 and end at 10. With this being the plus 1, right? So that's what we call a string slice, is accessing a subset of characters in a string. Okay, let's talk about immutable, how strings are immutable. So what does immutable mean? Immutable means it can't be changed, right? That's what immutable means. So we've been looking at, you know, this right here. This string at index 0 is the letter A, right? So if we print that out, we're going to get an A, right? Print it out, sure enough, we get an A. Well, during most of the course, you know, we have variables like we say A, excuse me, not A, say B is equal to 4. We could print B. We'll come back to the string in a second. We say B is equal to 4, and then we print B. Then we can change it where B is 5 and print B. You know, what's that going to print? That's going to print 4, and that's going to print 5, right? If you do it, sure enough, it prints 4 and it prints 5. And why is that? It's because we're saying B is 4, and then we're saying B is 5. Because B is mutable, meaning I can change the value of B. But when we say a string is immutable, it means the individual characters of a string cannot be changed. So if I print S at index 0, that's going to give me an A, right? What I cannot do is this. This isn't going to work. It gives me an error. The string object does not support item assignment. And it tells me, you know, it's on line 5. If you look at line 5, it's telling me my error is right there. And that's because I cannot change the individual value of characters in a string. You just can't do it with Python. Actually, a lot of other programming languages you can. But with Python, you just can't change the value of individual letters in a string. You can change the string itself, the entire string. So if we print S here, you know, that's going to print the alphabet. We can change the entire string, change the value. And that's 5. Excuse me, that's fine. Because we are not changing an individual letter in the string, we're changing what the entire string is. And this is fine. You know, see, that works out just fine. But we cannot do this. Again, it gives me the error on line 6 that you can't support item assignment, meaning I can't access an individual letter and give it a different value in a string. And that's what we call immutable. That's strings are immutable. That's the word right there, immutable, meaning the individual values of the string cannot be changed. Okay. Next thing, let's look at conditionals. So some of your other assignments, you already did some conditionals about checking different values, like if b is equal to 5, if b is less than 1, 2, 3, 4, 5, print okay, whatever. Short little contrived example. This is a conditional. You're doing some kind of comparison here to see if it's true or false. Again, if that comparison is true, we execute the code. If that comparison is false, we don't execute the code, right? If we run this, it's going to print okay because 5 is less than that. Of course, if we make this a bigger number, that's going to be false, and so it won't print okay, right? You've seen this plenty of times already. So this part here is what we call the conditional. It's something that can either be true or it can be false. Okay, well, how can we do similar things with strings? Okay, so let's imagine we'll use the same print okay, but what's some kind of comparisons we can do with these strings? The first and easiest one is what we call in. We say this in that. And what do I mean by that? What this will do, it'll check, is this string contained anywhere inside of this string? So for example, if we put A in S, so S, is this alphabet string here. So this is saying, does this A exist anywhere inside this string? The answer is yes, right? Because there's an A right there. If we run this, of course, it prints the okay. We can put G. Is G anywhere inside of here? And it is, it's right there. So that'll print okay. If we run that, it's okay. What if we put GG? Does GG exist inside the string? The answer is no. There is a single G, but there is not a substring called GG. If we run this, it doesn't print okay because this is not true. However, for some reason we did have GG in there. Now it is true, right? If GG is in S, it's true because right there is GG. And of course, it prints okay. Let's go back to just normal alphabet. Of course, we could do like W, X, Y, Z. That's going to be true because right there it is. Prints out okay. If we do Z, W, X, Y, Z, that's going to be false. Those individual letters do appear in there, but they don't appear in that same exact order, right? So that is not going to work, or it's not going to be true, so it does not print the okay. So that's how we can use in, checking if this string exists anywhere inside this string. So that's kind of like an equals to, or it's actually checking a substring, right? We can also have not in. That kind of does the direct opposite. It says, does this string not exist inside of here? And of course, if we put STU, right? STU does exist, but this is saying, does it not exist? So we're not going to print okay here because it does exist, but we're asking if it does not exist. If we run this, we don't get the okay. Now, if we put something in here that's clearly false, clearly this string does not exist inside of here anywhere, right? So it's saying, okay, this string does not exist in this string. So we have the in and the not in. We can also use equals. Let's make the string shorter. Better show these A, B, C, D, E. All right. So we're going to say, are the strings equal? Put A, B, C, D, E. So the string is A, B, C, D, E. We're going to say if A, B, C, D is equal to the string, print OK. Of course, we're going to get our OK. Right? A, B, C, D, that's not true. And of course, we don't get the OK. That's because it works differently from in. This says, are they exactly the same strings? In this case, they are not. That's kind of how the equals work. We have the not equals, meaning do the strings not match? Of course, if we put A, B, C, D, E, they do match, but we're asking if they don't match. Of course, no OK. If we make them differently, then this is true. They don't match. We get the OK. A little less intuitive is less than. And conversely, we can have greater than. We can have less than, we can have greater than. So we're saying less than. Now think about this for a second. Think back, way back to elementary school, when you compared words together and, which word comes first in the dictionary. And how do you do that? You compare letter by letter and determining, is there somewhere in that string where one character is, comes before another character. So if we have these two strings, A, B, C, D and A, B, C, D, E, which one would come first in the dictionary? The answer is this one would, right? Because you compare the A's, they're the same. So you go to the next letter. The B's are the same. Next letter, the C's are the same. Next letter, the D's are the same. Next letter. Well, this one doesn't have a next letter, but this one does. So that means this one comes first. If you're comparing them like dictionary wise, right? And so this right here is going to be true because this string, it does come earlier in the dictionary than that one. You see, we do get the OK. If they're the exact same, then this is false. This one does not come before that one. They're the exact same thing. So they'd be in the dictionary at the exact same time. We don't get the OK. And of course, if this one had additional letters, or actually A, B, C, D, if this had an F, you compare it letter by letter. Eventually you get to this last letter where they're different. So does F come before E? The answer is no. So this is false because this string would come later in the dictionary than this string. If we run it, of course, we don't get the OK. If the situations were reversed, if that was an F and that was an E, now it's true as far as the less than. And we get the OK. And it's kind of the direct opposite line of thinking. If you have greater than, it's saying, does this string come later in the dictionary than this string? So less than and greater than are kind of polar opposites of each other, but they work the exact same way. Right? Okay. Now here's the catch. There's always a catch, right? So let's go back to equals, seeing our strings equal to each other, right? So AAA and AAA, right? That's true, right? AAA is equal to AAA. That is true. And we get our OK. What about this? Capital AAA. Is this true? Is this going to print OK, or is it not going to print anything? So we're saying, are capital AAA equal to lowercase AAA? And the answer is no, they are not equal to each other. And so we don't get our OK. Really, in any programming language, and it applies to Python as well, capital letters are not equal to lowercase letters. They are different. And in the world of Python, capital letters come first. So if we put less than here, this is going to be true now. This is going to print okay because, you know, it compares it letter by letter. So is capital A less than lowercase a? The answer is yes, it is. Let's save it and run it, and we get our okay. And that's because capital letters come before lowercase letters. And it works the same way, you know, maybe not all of them are uppercase and lowercase. When it does this comparison, it looks at the first letters. The first letters are the same. It goes to the next letter. The next letters are the same. It goes to the third letter. The third letters are different. And capital A is less than lowercase a. So again, that'll print okay. You know, what if we had this? What if we have ZZZ, capital ZZZ? All capital letters come before all lowercase letters. So even though if you think about the alphabet, A comes before Z, right? But in Python, lowercase a does not come before uppercase Z. All uppercase letters come first. So if you think about it kind of like in a timeline, you have like A, B, C, D, etc., W, X, Y, Z. And then you have I'm sorry, the other way around. Then you have A, B, C, letter, W, X, Y, Z, more stuff. That's kind of what it looks like with these dots, you know, being other various letters and characters and stuff like that. But if you're looking at what comes before, which letters come before other letters, all of the uppercase letters come before all of the lowercase letters. And so that kind of applies, let me put that as a comment. That kind of applies when you're doing less than or equal to or less than. It applies with equals to, it applies with not equals to, it even applies with the in. So let's have AAA. So let's say, does capital AAA, is that in S? The answer is no, right? You know, it does not print out the okay because capital AAA is not in lowercase AAA. So that's a very important aspect you need to remember when you're doing these conditional checks. Okay, let's move on to the last material to cover, and then we'll talk about the assignment. So what are some functions that we can do with strings? There are actually a lot of Python built-in functions we can do with strings. Let's get rid of this stuff. Let's make this just QWERTY, you know, whatever. Just make it a string we can work with. So first, let's print what is the type of S. You've seen type so far already to tell you if things are an integer or a float or a string. We run this. Of course, it tells us that the type of S is a string. That's what the str is. It stands for string. Okay. Let's talk about uppercase and lowercase. So as we saw here, let's go back. If QW, I see, for the example, we'll leave it as an example. That in S, then we're going to print okay, right? Oops, fix it. There we go. So it'll print okay if capital QW is in S, right? We've already seen that this is not going to print okay. Now, it does not print the okay because capital QW is not in there, right? Well, let's imagine that you didn't care about the case anymore, right? Let's give a good example here. Let's say we had UMGC, all right? Good old college, we're going to UMGC. So we're going to say if if lowercase um is in this string? The answer is no. Oops, rerun it. Of course, we don't get anything printed out. That's fine. But let's say we didn't care about if it's uppercase or lowercase. How can we tell if the letters are inside this string, but we don't even care about the case? Well, for this, we could put right? And now we're going to get it. We're going to get okay. But what if it's this? What if the string was lowercase and we're still checking for uppercase? That's not going to work. You can say, well, we changed this back. Okay, that works. What if you don't know that? What if enter a string? So now we want to see, is UMGC anywhere in that string? So if we run this, enter a string, have some letters, I'll go ahead and put UMGC in there, some more strings, and that gives me an okay, because right there is UMGC. Let's run it again, some more letters, UMGC, some more letters. It does not give me the okay, even though it has UMGC, the case is not matching, right? I could even do, well, maybe you think you'll do this. LF UMGC in S. Print. Okay, again, whatever. Maybe you think, oops, that's not quite right, is it? There we go. Maybe you'll think you'll catch it like this, uppercase and lowercase. So how's that work out for us? All right, let's run that. Type in some letters, UMGC in lowercase. Okay. Type it in like that, UMGC in uppercase. Okay, it gets us again. But what if we type in big U, little m, big G, little c? That doesn't work. So what if we want to catch it no matter if it's uppercase or lowercase? We have a Python function called lower. What this will do, it will treat every letter in this string as if it was lowercase. So even if you type in uppercase, it's going to consider everything lowercase. So what happens here? Let's print the S. Let's take this out for a minute. Let's print the S. Let's do s.lower, print S, and then let's do S equals s.lower and print the S. Three different things here, right? So here we're going to input a string and just print it out. We're going to do s.lower and print out the string, and then we're going to have S equals s.lower and print out the string. Let's see what happens, and I'll explain to you why it happens. So enter a string. I'm going to do all uppercase QWERTY. So here's what we get printed, right? First, we print exactly what I typed in, which is this QWERTY. Then we're going to do s.lower and print S. We still get the uppercase QWERTY, and I'll explain why in a second. And then we're having S equal to the s.lower and print it out, and that's when we get the lowercase QWERTY. The reason being is what I talked about when a string is immutable, meaning we cannot change the value of individual characters. So when we do the s.lower, it will return to you the string in lowercase, but it doesn't change that string. So when we do s.lower, it's not changing the individual characters of S. But the reason why we get it in the last one is because we're changing the entire string. We're saying this variable S is equal to the lowercase letters. So that's how we get this lowercase. And conversely, we could do upper here. And instead of lowercase letters, it'll give us the uppercase letters. So we run that. Now, if I type in lowercase letters, by the end where we do this S equals S.upper, we get the uppercase letters. So how does that help us? Well, now we can say if UMGC lowercase in S, print found it, right? Save it and run it. So no matter which way I type in, oops, I'm sorry, let me put lower, right? Got to remember to change it to lowercase. So no matter if UMGC is in uppercase or lowercase or a combination of it, this will find UMGC in there. So let's enter a string, all lowercase, found it. All uppercase, found it. Mixed case, U, big U, little m, big G, little c, found it. The other way you could do this is instead of lower, you could make this uppercase, but then you would just have to use the upper here. Does the same exact thing. I'm not going to go through all the examples, just the mixed case again. Found it. So that's how we can use the dot upper and the dot lower to find a specific string within what you typed in, irregardless of if it's capital or not. What if you want to find a specific string, find out where it starts? We have another function. We're not going to do, let's just call, what's called, we'll say I is equal to s dot find. Let's just look for a lowercase u, and we'll print I. What s dot find will do, it'll find what is the index of where the first character of where this first thing exists. Let's show the example. So if I do this, if I type in A W U A S, whatever, the U is in index 2, right? Because A is 0, W is 1, U is 2. It tells me index 2 is where the U is. What if I don't have it in there at all? Just type this in, there's not a U. The find gives me -1. -1 means this does not exist in there. And it doesn't have to be an individual character. It could be UMGC. This will tell me, where does UMGC start? If we run this, if we just type in UMGC, it tells me it starts at 0. And that's right, because it starts at 0 right there. If we run it again and do it like that, UMGC starts at index 1 right there. And of course, if we do it and we don't have UMGC at all, it tells me it's -1, meaning it does not exist. So this is how you can find where in the string a specific string starts. All right. Last two things, and then we're going to have to wrap, and then I'll talk about the assignment for a second, and then we'll have to wrap it up, is two more functions we want to look at. We'll look at s dot starts with and s dot ends with. Kind of looks like this. Print starts. And print ends. And what you need to put in here, you need to put what you're looking for. So let's keep on the UMGC theme. We're going to say, what are we saying here? We're saying this string S, does it start with UMGC? This is saying this string S, does it end with UMGC? And it's just what you would think it is. Does a string start with that or does it end with that? So let's run this. If we type in something where UMGC is not in it at all, it doesn't print anything because it doesn't start with or end with. If we type in something, if it has UMGC in it, it still doesn't print anything because it doesn't start or end with it. Well, if we type in something, this does start with UMGC, then it's going to print starts. If we do it and it ends with UMGC, it ends with it. And actually, if we just type in UMGC, it actually starts and ends with it, right? All right, so that's all the material for this week. Let me give a couple pointers about the assignment. Your assignment this week is to do a password validator, meaning you need to make sure the password meets a minimum length and a maximum length. Make sure it has it talks about make sure it has a special character in there. It says make sure it has the substring UMGC. Actually, it says make sure it does not contain UMGC, which I think we've covered that pretty thoroughly. So if you think about it, so meets min and max length, right? How do we do that? The length of S tells us how long it is. We just need to check, does that fit within the min and max range, right? The next thing is cannot contain UMGC, right? How do we do that? Something like if UMGC in string, right? That'll tell me if it's in there, right? And then it wants to know, finally, it must contain the hashtag symbol in some position other than the first or last. So it has to have the hashtag, but it can't be the first character. It can't be the last character. So, the first character is that, right? The last character is the length of S minus 1. That's the last character, right? And then if S dot find whatever character you're looking for, minus 1 if it doesn't exist, the index value if it does. That's kind of some pretty good hints, probably more than I should give you really, about how to do this assignment. All right, I got a few more minutes for questions, so go ahead if you have any questions.
No questions, but thank you for your time.
All right, I'll go ahead and end this then and get the video posted. Thank you.